There's something new from our sponsor, Text Control. For decades, TX Text Control's rendering was tied to Windows functionality. But now it's a new era. TX Text Control is platform independent. You can run your .NET applications on Windows or Linux, deploy with Docker containers, Kubernetes, or host directly in Azure App Services. Seamlessly integrate document editing, signing, collaboration, and PDF processing into your ASP.NET Core and Angular applications. Are you ready to see it in action? Check out the live demo at demos.textcontrol.com. That's demos.textcontrol.com. Hi, I'm Scott Hanselman. This is another episode of Hanselminutes. Today I'm chatting with Pamela Fox. She's a principal cloud advocate focusing on Python at Microsoft. She worked at the Khan Academy and did all sorts of amazing stuff, and was also a developer advocate at Google for a time. How are you?
I'm doing pretty good. Just recovering from Build and PyCon.
Yeah. Why would they put those two conferences near each other? What was that about?
Well, traditionally, Microsoft developers don't use Python, right? When I joined Microsoft, 3 years ago, Python was kind of the underdog where people were like, oh, let's like try to get a few Python developers using Microsoft stuff. And then, of course, AI came along, and now Python is the first language that gets an SDK when we have new Microsoft technologies. And now .NET is like, hey, what about .NET? I mean, you're a .NET person, so you can say what it's like being a .NET person.
I am a .NET person. I think of myself as being non-denominational, but like, why can't we all just get along is my perspective. But it is interesting how, like, 5 years ago, you would have asked me, like, which language won? I would have said JavaScript. And then Python's like, hey, here we go. You know, like ML AI is having a moment, and Python is certainly having a number of moments. So I guess there's lots of languages, and that's okay.
Yeah, I try to also be non-denominational when it comes to languages, or just generally in life as well, just so that there's less fights and wars in the world. But I do sometimes think it's so crazy how much time we spend rewriting the same things in different languages. Like if an alien came down to Earth and they evaluated our state of programming, they'd be like, why do you have 20 different languages? Right? Why do you have this proliferation? You could, like, as a society, you could be more productive if you had, a single language.
I have this analogy that I've told before, and it offended a number of people in Northern Europe, but I will use this analogy for you, and you tell me what you think. My son and I were in Finland, and I think he was 16, and the Finnish language is very strange. And he said, why do they bother? They're not going to win. And it was such a ignorant teenager thing to say. But at the same time, like, if you look at it from an alien coming to Earth perspective, it's like, do we need custom languages for all these people? There's like 8,000 million people on the planet. Why do they need their own? And, why can't we just all speak English? And then I realized that JavaScript is like the English. It's just this crazy language that colonized everything and stole from all the other languages. And it's not the language we deserve. It's the language that we ended up with. So why do Finnish people bother? And it's because they have art and culture and poems and songs and, plays. They want their language. So why does Erlang bother when Python is winning? Why does any language bother? People just like to not invented here syndrome. They want to make their own thing. It's the only answer.
Yeah. I mean, when it comes to natural languages, I will defend those to the death, because natural languages. I did a minor in linguistics, and I actually my research, was around multiple languages and how they kind of connect to each other and whatnot. Because it's just beautiful when you learn another language, and you'll learn a word that exists in a language that doesn't even exist in English, and you're like, oh, we need that word. I know German is famous for them, but in Portuguese, they have the word saudade, which is, you say oh, estou com saudade para você. It means oh, I have this huge feeling of missing you, right? So it means missing, but it's I don't know, it's got all this other stuff wrapped up in it, and it's just beautiful. And So it's like, like having all these languages, because like the richness of human experiences, right? Like I did a research project about spatial prepositions, and I wanted to teach a computer spatial prepositions, meaning like over, under, around, that sort of stuff, right? So in order to figure out how a computer would learn it, I first read like a whole textbook about spatial prepositions across languages to see how different languages do spatial prepositions. Because some of them will be like, we'll talk about like, oh, on this side of the mountain or the other side of the mountain, right? Because that's how it made sense in their culture to describe places. So then when I taught the computer spatial prepositions, I used, I think, 3D Studio Max. It was a 3D modeling package, and had it like measuring like different angles and relations to each other. And then it would like form a decision tree and then learn the prepositions, right? But that I think is what's beautiful about languages, is that we have so many different ways of viewing the world. And if you learn a new language, you can actually like change the way you view the world.
Yeah, there's that whole myth about the number, like Eskimos have 90 words for snow and that kind of thing. But as a general rule, like I've noticed in my relationship with my wife that I'm very much cardinal directions and she's very much relativistic. Mm-hmm. And I was surprised that like English doesn't have more precise ways of describing direction. For her, it's very much like go to the monument, hang a left at the statue. And for me, it's like head east 300 yards. Turn left 90 degrees. I'm basically a logo robot, and everything that she does is 100% relativistic, and I'm very much absolute. And I'm frustrated sometimes that I don't have the support language to get through those situations.
Yeah, I'm one of those people. If you tell me to go north, I'll just go uphill, because I just think
our big argument is which way the GPS map is like oriented. For her, the Earth has to rotate around her, and for me, north is vertical. Like north is up always. So if you have a background in linguistics, did you see AI and things like vector embeddings coming, or did you just happen to study the perfect thing for your chosen work?
I wasn't like up to date with linguistics research. Like I didn't do a PhD or anything. It was just a minor. But I was happy when, I am happy that LLMs are a thing now, because I feel like I can finally bring in my language background. Because traditionally, like computer science wasn't that associated with language. Like if you were applying to a computer science camp or course, they would look at your math scores, right, for the SAT, right? Like there was I went to computer camp when I was a kid, and in order to qualify to go to the computer camp, they would look at your like SAT score, and they would only look at the math part, because they thought like, oh, math, computer science, right? So there's always been this connection between math and computer science. There hasn't been that strong of connection between language and computer science. But even in college, I did my compilers class at the same time as my linguistics syntax class. So I was literally writing parse trees for computer programs at the same time that I was writing parse trees for like English and Japanese sentences, right? And I ended up doing so well in both those classes that like I ended and I set the curve, yada yada. Because like I was doing parse trees everywhere, and my whole life was parse trees at that point, and everything just clicked and made sense, and I could see the world as parse trees. It was like the Matrix, and yeah. So I think from an early stage, I've seen the connections between computer science and language, and it's very convenient that now I get to bring more language into computer programming.
It sets you up for success, 100%.
Yeah. I mean, it helps. There's still a ton of math involved in LLM. So now I am wishing that I paid more attention in the linear algebra class in college. The thing is, during the class, they didn't say what linear algebra was used for. They didn't say like, hey, by the way, like linear algebra is the basis of computer graphics renderers. Linear algebra is, in the future going to be used for LLMs, right? At the time, I didn't realize how useful that class would be. So I do wish I had a bit more linear algebra expertise, but I have been trying to make up for that by reading lots of books that do lots of matrix math.
Mm-hmm. Do me a favor, and let's try to put our professor hats on and talk about vector embeddings in a way that doesn't float away like a helium balloon and get up into the like high complexity of it. Because I think analogies are a valuable way for us for myself rather, as a lay person and perhaps folks that are listening, because I feel like when we have conversations about how LLMs work and how they think, and I put think in quotes,
Mm-hmm.
It floats very, very quickly. You can have well, it's kind of like a parrot. And then we go, and here's the vector embedding, and here's the math. And it's like, whoa, whoa. And there's no space between the two. I want
Mm-hmm.
to understand the idea that a vector embedding is a way to represent relationships. Help me understand that. So embeddings are just numbers. Where's the
Mm-hmm.
magic there?
So yeah, the vector embedding, well, it's a vector in multidimensional space. So, we can't visualize thousands of dimensions, but I just always think of it as an ice cream cone.
Hmm.
Imagine your ice cream cone full of vectors, right? And you've got a vector for dog and you've got the vector for cat, and those vectors are quite close to each other because a lot of times cat and dog would be used in very similar situations, right? So the dog sat on the mat, the cat sat on the mat, they can both sit on the mat. I have a pet dog, I have a pet cat, right? They have a huge amount of semantic similarity, right? So those two vectors would be, closer to each other in this vector
When you
space.
say closer to each other, are they I'm imagining arrows heading in the generally same direction, in the kind of like small furry things with 4 feet direction? Is that what we're trying to say?
Yeah, the tricky thing with the vector embeddings is that we can't like actually say that a particular dimension means small furry things, because
Mm.
we've turned this very multidimensional world. Because if you think of all the possible ways you could describe something, there'd be like millions of ways to describe something. It'd be like things you can own, things you can pet, things you can feed, things that are canines, right? There's too many dimensions, right? So they've been reduced down. But yeah, you could generally think of them as like, okay, that they're like pointed in the same direction of furry things we can pet.
But who decides? Right? Because
The
you're saying that
internet.
we've abstracted. So the decisions are not made absolutely. The decisions are made relatively through the just creation of a corpus of text. So
Mm-hmm,
when
mm-hmm.
someone makes a Ghostbusters quote, cats and dogs living together, mass hysteria, which is a very generational quote. Like you either grew up and you know that quote, or you're under 30 and you've never heard that quote. That text appears on the internet millions of times
Mm-hmm.
because of Ghostbusters, not because of anything specific to dogs and cats. But cats and dogs and cats, those words are always near each other. Does their proximity then cause, for lack of a better word, bias, where dogs and cats are always together, but like hamsters and ferrets are like getting the short end of the stick when it comes to like furry things?
That's a great question. It is going to be based off of it's going to be based on both the data that the embedding model was trained on and just the way in which they like fed that data into the system, right? So for example, like if you want to, you can make your own embedding model using the word to vec algorithm, and just feed in whatever data set. Like I did it using the Google News data set. So that would tend to, base its idea of relationships based off of what it sees in Google News. Most of these embedding models and ones we're using these days, like the OpenAI Text Embedding 3 series, those are generally based off the whole internet, right? So they may have some bias from that Ghostbuster quote, but I think there's a lot more cats and dogs
You think there's
out
a lot
there,
more
and I
cats
think
and
you,
dogs?
I think so. Yeah, I think you'll also find hamsters and ferrets do show up together in other places, like on
Mm-hmm.
pet websites and stuff. So yeah, and also they did find like when they found like bias in like some of the early GPT models, especially from like Reddit. Like there was a famous Reddit user that had his own token. A token is like a unit of measurement that an LLM learns as it sees something a lot. So this one Reddit user had its own token for their like crazy username just because they trained on the Reddit data and they
Mm-hmm.
accidentally like learned too much, like they put too much importance on what they saw in that Reddit data. So I think that we've learned things from training these models that we do need to clean up the data more. So I think the models these days do try to do have cleaner data, or at least they do a pass with cleaner data. Sometimes you like start off with the messy data, like the whole internet, in order just to teach it how to speak languages. And then you go back and you do another pass with nice data. And it's like, okay, you learned how to speak according to the internet and Reddit and all this stuff, but this is how we like actually want you to speak, right?
That was
and
my
they might
next
do
question.
something with embedding models. I don't know exactly what approach they've used for embedding models.
Yeah, but it's an interesting thing to talk about because we were saying the nice data versus like the messier data. I was in my mind as I was formulating the question was there is what I would call formal data, like a book that was published, that was like thought about and intentionally created, sold, edited, and made the New York Times. And then there's like shit posting, right? And like we don't know, just like we don't know how much dark matter there is and the space between the stars. I don't know the difference between formal, appropriate scholastic text versus just like tweets. And if the internet is 90% just user generated crap and 10% books, or vice versa. And I'm wondering if there's any way for us to have a sense of what the LLM has learned from.
Well, generally, when a new LLM comes out, we can look at the model card, and the model card describes the training process and also describes it. Sometimes it'll describe the training data. It just depends on whether it's one of the more open models or doesn't depend on the name of the company.
Weights?
Open weights means you can actually run it locally, but if you have open weights, it doesn't necessarily mean that what it was trained on. So you could have open weights and still not have any idea what it was trained on. But the nice thing about open weights is it does mean you can run it locally as long as you know the weights plus the algorithm to use. But yeah, knowing what it was trained on. For example, like I was looking at an open embedding model, Nomic, and they have a new version that just came out recently. And so this is an embedding model you can use locally with like Olama. And they specifically were trying to make it work well across different languages like English, Spanish, Korean, Hindi, like all of that. And so in their training data, they tell you what percentage of like exactly how many tokens. That's what they do is they say, this is how many tokens came from Korean. And this is how many tokens came from Spanish. So then at least you get some transparency into the language distribution. And sometimes they'll also say where it came from, like, oh, it came from the books corpus, or it came from this corpus, right? And then you could get a feel for what it learned from.
Hey friends, it's time to pay the rent. We're going to take a pause here and have a chat with our new sponsor, Sharegate by WorkLeap. I've got Shaylin Gimby on the line. Shaylin, if you had 30 seconds to explain why Sharegate makes IT teams' lives easier, what would you say?
All right, start the clock. Everything IT teams need to manage Microsoft 365 comes out of the box, no manual needed. Flat, transparent pricing, no data caps, no per user fees. From planning migrations to keeping your environment clean and secure, we take the heavy lifting off IT's shoulders. And when you need help, you get real support from real experts. Sharegate makes Microsoft 365 management simple so IT teams can focus on what really matters.
That was exactly 29 seconds. That was impressive. Very, very impressive. Just as is Sharegate by WorkLeap. You can check them out at sharegate.com. It's one tool to migrate faster and secure your tenant. It's an out-of-the-box Microsoft 365 migration solution. You can check them out, sharegate.com, and we thank them for being a sponsor of Hanselminutes. While we know that everything's biased towards English because there's so much English, but there's also a lot of Chinese and a lot of Arabic, is it good for a model to be multilingual, or is it best for it to focus on a language?
Oh, that's a good question. I would say that it depends on your use case, right? Like if you're building an app and your customers are only speaking a certain language, then like if you're really specifically targeting, like the Chinese audience and they're, very strictly using Chinese with your app, then you probably want one, you would want to pick one that's really well suited for that language. In the US, I really like to use the multilingual LLMs because they, because in the US is well, we're supposed to be a melting pot, and we have people who speak all kind of language. Like in California, like 50% of the people here speak Spanish, which I think is awesome because I just walk around and get to like speak Spanish all day. And so people love then that the fact that we can, build an app and then they can deploy it, and then their employees can type a question in Spanish in it, they can type a question in English, and they can get back responses either way, right? So so I like to find ones that are doing a good job across the main languages that users might be using, but I definitely think it's important that people are building models that work really well for languages that otherwise aren't emphasized in the training data, because we have this big risk of becoming English centric. Programming kind of started off English centric for whatever reason, and it would be a shame to miss out on all those beautiful languages because they all have such.
We don't want to disrespect Finland. I was meeting with someone at the University of Venda in South Africa, and they speak Tshivenda, and there's like maybe 1 million people, maybe 2 or 3. It's kind of in South Africa and parts of Zimbabwe, and he wanted to know when Copilot would be in Venda. And it's like, there's like 8,000 million people, 8 billion plus people, and this language is like 1 million, maybe 2 or 3. Like, is there enough text? And I'm just picking Venda as an example. It could be an indigenous North American language. It could be anything. Like these languages that have 1 million people as a general rule. Is it the number of people that speak it, or is it the amount of text that can be publicly found? Because there's also a lot of conversations about if you're going to have like indigenous Native American models, who owns it and who controls the bias, because you want to bias it in a way that makes sense to the culture. It seems like we're certainly fine when it comes to English. Like there's enough text, but like, is there a sense of how much text needs to exist before you can have a useful chatbot in a language?
Yeah. So I'm just looking at the nomic embed model, right? And so, for example, for English, they bring in 234. Is that million? Yeah, 234 million examples. So it pairs, because this is for an embedding model, right? So 234 million pairs versus like Igbo. Igbo, that's a language in
Igbo is Nigerian.
Nigeria,
Igbo.
Yeah. And so that one, Igbo. Okay.
No, I think
so
the
that,
G is silent.
Oh, you don't even say the G. Okay, Igbo.
It's like I mean, I could be wrong. Neither of us is Nigerian, but it's kind of like the G is kind of like it's there, like cookies and cream. It's just kind of like Igbo. But I could be wrong. We're going to get Nigerians texting me instantly after this.
I've read quite a lot of books from, there's a Nigerian author that's really good. But when you read a book on text, you don't get to hear.
Yeah.
So for that language, they only brought in 32,000 pairs, right? So that, and the smallest language is Yoruba. Which,
still a big number.
Also said wrong. That one, they only brought 16,000 pairs, right? So for the range for this model was between 16,000 pairs to 234 million pairs. And that, a total, they had 1.6 billion pairs, right? So, there's way less representation of, the some of these languages here. And these pairs came from multilingual news. If you're wondering, like, where do you find these news? So they find like news articles that have been translated into all these languages, because that's fairly high quality information.
Good point. Yeah, news articles certainly makes more sense than just random social media, because random social media would lean the vectors towards casual rather than formal speaking. Like it could be a conversational representation of how people talk the language, but not necessarily how you would write a newspaper article, or if you were going to run your PhD thesis through a Copilot. Formality is a vector, isn't it?
I think formality is a vector. Yes, part of the dimensions.
These dimensions, we say multidimensional space. We can visualize 2 and 3 dimensions. We struggle to do 4, and then we're talking about like low dimensions within the context of a vector embedding is like 50, and thousands of dimensions is typical.
Yeah. So the OpenAI Text Embedding 3 large model is 3,072 dimensions. That's the largest model that I've worked with. And it's so large, it actually doesn't fit in a lot of vector databases. Like PG Vector recently had to make a change just to be able to support this model, because they didn't have a notion of being, because it's just a list of floating point numbers, right? So they didn't have the ability to store a list of floating point numbers that was greater than 2,000 numbers until very recently, right?
Wow. So then
So
there's
yes,
this thing
they're
that's
large.
called the curse of dimensionality, where like we're coming up with relationships, happy, cheerful, joyful, kindness, and then start moving on all different directions around. You're kind of limiting the thesaurus as you look for ways to describe words that are close together, and figuring out what dimensionality, like a dimensionality could be. Make the word more formal. Make the zhuzh it up a bit more. Like zhuzhing could be. I had to tell someone how to spell zhuzh recently. Like all of these dimensions are, and they're not necessarily named, right? They're just dimensions. They don't have there's no if you have king or queen, there's no gendered dimension, but there is a dimension that if you said, give me a monarch, make them very male, give me a monarch, make them very female, you'll get king and queen. But that doesn't necessarily imply that the vector has a name. Is that correct?
Well, so that's interesting. So Word2Vec was the embedding model that we used for a long time. And I was saying that's the one you can train yourself locally fairly easily. And that one is a very, very strictly based off semantic representation based on like fill in the blank, right? Like if this would go in the blank and this could also go in the blank, then that makes them more similar. And that Word2Vec model is famous for being able to do like vector math. So if you have king and you like minus queen, you like get back the vector for female or male or something like that, right? So you could actually do this vector math, and people have had a lot of fun doing vector math to see what happens when what happens when you add these vectors and whatnot. But if you take the new embedding models, they are not so strict with being exact semantic representations like that. Like, for example, the first OpenAI model, one of the first ones was text embedding Ada002. And that one, if I search for what's most similar to dog, then I get back God as the number 2 most similar thing. It goes dog, cat, and then God. And then farther down that, like, it's like number 6 is drug. So,
okay.
It's
Why?
not. It's a good question as to why. Like, it just depends on how they trained that model, and I'm not privy to how they trained it. But I assume that with that particular model, they must have been training it in kind of a character by character way, because you kind of see these spelling similarities, right? Like, I assume that dog and God are similar because if you accidentally typed it in reverse, you would get God. Drug and dog are similar because you make some mistakes and suddenly your dog becomes a drug, something like that. So I think that model was trained with like in a way that it was looking at character similarity and like kind of spelling similarity. But then the newer models, I did the same experiment there, and they basically fixed it. So now dog is not directly similar to God and drug.
So when you say fixed it, though, that's a bias of a kind, because someone is then tweaking and waiting and putting their thumb on the scale and deciding, like, what do we want this to do? So these become less technical problems and more, for lack of a better word, PM issues. Like these are like program manager figuring out the requirements for a model.
I mean, maybe dog should be similar to God, right? Like if you wanted something that incorporated semantic similarity. And another cool example is that when you do multilingual stuff, right, I get vastly different results based off of whether I use accented characters or what we call like normalized characters, like the strict ASCII character set. And a lot of times it's actually I get better results when I don't use accents. And I imagine what happened there is during the embedding training phase, they might have normalized all the accents, right? We don't know. That's like another decision that somebody made, which was how do we deal with the fact that like other languages have accents,
right? And some people ignore them,
and some people ignore them. Yeah. So like I usually I'll always enter in like El Rey Leon, or however you say Lion King in Spanish, right? And you can do an accent, you cannot do an accent. And I'll get better results if I don't use an accent. And so that's another thing. Like if you are working with non-English languages, you do want to like experiment and try to like see how the model is responding to different ways of, treating the characters in that language.
When I do RAG, when I do retrieval augmented generation on a large amount of PDFs, I need a vector database. What ends up getting stored? And what is the relationship between all the text that I'm stacking on top of all the other text, right? Because there's the corpus of the model that I picked, and then there's my folder full of PDFs in whatever language they're in.
Well, so when you do RAG, you send your documents through a data ingestion pipeline, which just means that we look at the document, we try to extract the text from it, maybe even extract the images, and then split the text up into chunks. And, the chunks, maybe are a couple paragraphs. There's some research as the best chunk size, whatever. Like, so you split them into chunks that are a few paragraphs. And then for each of those chunks, you compute the embedding for them. And then then you store both the chunk and the embedding and, like the page number and the file name it came from, so that then you could make a citation later. So then when you're using your actual RAG application and you do, you ask a question, then we use that question in order to search the database. So basically we make a query based off that, we make a vector based off that question that you asked. And then we compare that vector to the stored vector. And then hopefully we also do like a keyword search, just because keyword search is also still helpful. Everyone's obsessed with vectors, but we still want to do full text search. So in ideal situation, we're doing both a vector search and a full text search, and then merging them together. Yeah. So that's be a hybrid search. So I always recommend hybrid search because, oh my gosh, you get crazy stuff if you only do vector search. Because what people often forget is that if you do a vector search, you will always find a result, even if it's really far away, right? Even if their vectors are, pointing in opposite directions, if that's the closest vector, then that's the result you're going to get. And so it's really important that you find ways to avoid the noisiness of vector search because it can be very, very noisy. But yeah, so we compare the vectors for your question versus the vectors that are already stored for that chunk, and then get back the most relevant ones. So we've been talking a lot about vectors for words, but these days the way we're using vectors is often on something much more complex than words, right? And so, it's cool to see what sort of results we get back when we search dog and we get back cat. But what actually matters is like, okay, we have this user question. How is that getting us back the best results in terms of our document chunks?
Yeah. And the idea of like best results comes down to user intent and correctness and expressiveness. And there's the, like if you say, give me the latest information on diabetes research, then you've indirectly biased it towards recency, and you might end up getting the wrong results because latest could be from the 70s or it could be from last week, but it depends on how it thinks about latest. And then you don't know if the data was ingested with the date being really like was the date the date of the document or the date of the metadata around the document or some text within the document. I've found temporal data searching to be really challenging in RAG.
Yeah, I would actually not use vectors at all for that aspect for temporal searching, because the thing is that, okay, so first of all, like vectors for numbers are like vector similarity between two numbers, doesn't necessarily mean what we think it means, right? So anything that involves numbers, that's, once again, where I'm going to use full text search. But that specific question, you're looking for latest. What I would do, so I always put a pre-processing stage in a RAG flow, right? So I get your query, I look at it and say like, oh, are there some filters I should pull out of this query to apply to the data before I do a search of the content, right? So you say latest, like, okay, I can turn that into a filter that says, filter the data to only get me back things that were sent in the last 1 year, right? And so then we filter that down first and then do the vector search, right? So that is going to get you better results than relying on vector similarity for latest, because that's just way too fuzzy, and I would not trust vector search for it.
As we get towards the end of the show, let me ask you this hard question. Is the distance between the kind of conversation that we're having here, which is still pretty basic, still pretty remedial, and the regular folks that are just wanting to ask the LLM a question and get an answer, like, you don't need to understand how the internal combustion engine works to have a successful drive to the shops, but it's nice. It changes your relationship with the car if you understand what's going on inside. Your relationship with any chatbot is going to be very different than mine because you know more what's going on inside. But then non-technical parent or non-technical child is going to have a very different relationship. How much should people know about this stuff to be consumers of this stuff?
Yeah, that's a great question. And so one of the most important things to me is just understanding the difference between getting an answer from RAG versus getting an answer from the weights, right? Because if you ask an LLM a question and it doesn't have any additional context and it's just based off what its weights, then you're only getting back what's what it was trained on, right? And as that's the most likely to yield inaccurate data because it doesn't have access to latest information. Versus if you're using it with any sort of RAG tools, like if you go to ChatGPT, like ChatGPT can now search the web, right? And it can search the web if it thinks it needs to, and it'll give you citations, right? Or if you go to bing.com, if you do a search, right? So if you see citations, then basically it did RAG. And that's the big thing I try to tell people is like, if you see citations, that is RAG. That's good because then it means that the LLM looked at some context and now you can go off and check at that context yourself. And then you are empowered if you choose to go and dig in to the sources and see if they actually agree with it. So I at a high level, like that is one thing I want people to understand, because we had this whole debate a week ago on Blue Sky about, do LLMs search the web? And I contend that LLMs do not search the web. LLMs are still just next word predictors. Right. However, an LLM can look at your user question, suggest what would be a good web query, and then our code, our application code, can then say, oh, okay, we're going to go search the web. We're going to get back results and we're going to feed it to LLM and say, hey, here was the user's query. Here's the results. Answer the question, right? And the LLM is going to generate text based off of all of that stuff, right? So the LLM is not searching the web, but an LLM is helping us decide what we should search for and then synthesizing an answer based off those results. But we, the application developers, are building the tool that searches the web.
I want to call out a really interesting example where I think it was Rasinovich asked some question like, is it 2025 to Google? And Google has their AI answers thing. And it was like, no, it's 2024, right? So it was clearly not doing any tool calls. It was just telling us the date that it was trained on. But then I tried it with like Bing, which uses Copilot, and that gave me the correct answer. But we don't know if they searched and then figured it out. And then like the tool call was the web. But the AI that I have been personally the AI search engine, I'm putting that in quotes, that I was most impressed with is DuckDuckGo, because they do the search and the summarization appears to be what appears on the page. And like that sounds silly, but it's like Google's web search AI thing seems to be the most black boxy of them, where it's like, I did some magic Google stuff and here's the answer. But it's clear that with DuckDuckGo, the results appear, and then the AI thinks, and then it tells me basically what's happening on the page below you. And what I liked about that from a user interface perspective is it's like, oh, that's very intuitive. It's the TLDR of the results, as opposed to trying to glean my intent and figure out the answer without looking at the results. And that makes it feel very comfortable.
Yeah, that's really nice. That's one of the general best practices for design of AI-based systems is transparency. Microsoft actually has this really nice HAX design toolkit, is what it's called. And it has all these design guidelines, but more importantly, it has all these examples where they've like screenshotted apps from all over, from Microsoft, from Google, et cetera, where they say like, here's a nice example of this design principle. And one of the big ones is transparency, right? Where you can see like, okay, the LLM has this amount of confidence in its answer. The LLM based its answer on these parts of the text, right? So as much transparency as you can give people, because then maybe we can start helping people to understand what the LM is doing and what it isn't doing so they can use it best.
Yeah, that is great. I like looking at examples of like UX. I feel like that's a really interesting conversation. I had Maggie Appleton on the show a while back talking about what the UI for AI is. And it's bigger than just a text box. There's so many good examples of like, this is transparent and thoughtful and clear and responsible and fair without hiding stuff. And I feel like I want a little sparkle or a little square around the thing on the page that says AI generated. I want to know when, why, and how this was done, and did it express my intent? And knowing how all these, learning at least from you how these vectors work and the complexity of it has been super helpful. Thanks for spending time with me today.
Sure. Yeah. And for the record, I don't think most people need to understand how vectors, like the lay people probably don't have to understand vectors, but they are just really fun to dig into.
If you like learning about this stuff, you can check out Pamela's blog at blog.pamelafox.org. She has a great article from May about visualizing vectors and a lot of other great blog posts going back many years. This has been another episode of Hanselminutes, and we'll see you again next week.